We're looking at the square root function. The square root function is given by f of x equals the square root of x. Again, we're going to be answering all the same questions we've been doing. This is halfway through our 12 basic functions. And as we have done on all of them, we're going to plug in some points to get started. And again, this is going to be the square root of x. So I'm going to start with -1. And when I plug in the square root of -1, from Algebra 2, we should be remembering that you can't take the square root of a negative. The square root of a -1 is equal to I, an imaginary number, which we cannot graph. So that means that there's nothing that exists if we plug in a negative number. So the first number we can actually graph is 0. So the square root of 0 is 0. 1. The square root of 1 is 1. Now, I'm going to go then to 4. So the square root of 4 is 2. And square root of 9 would be the next easiest one to do, which is 3. So again, I skipped this time. I didn't go in numerical order or in a 1, 2, 3 sequence because I needed to make sure that I could take the square root. I didn't want to have weird numbers. So I start at 0, 0, 1, 1, 1, 2, 1, 2, 3, 4, 2, and then at 4 I go 5, 6, 7, 8, 9, and 3. And there is our square root function. So our domain is not going to exist back here. So our domain is 0 to positive infinity. Our range, again, nothing below, so we're going to be from 0 to positive infinity. And this is continuous for the graph. We're not going to pick up our pencil once we start plugging in a number. Every number will lie on this function. It is increasing, meaning as the x's go up, so do the y's. And it is increasing from 0 to positive infinity, and at no point will it be decreasing. It is not symmetric, so we have no symmetry, and it is an odd function. Or sorry, you know what? We don't even have that this time. Excuse me. Let me erase that. All right, it is bounded from below. It has an extrema, which is the lowest possible point on this graph. So it is an absolute minimum at 0, 0. There is no horizontal or vertical asymptote. Now when we look at end behavior, so as x is going towards negative infinity, nothing is going to happen. We're not able to do that. So I'm going to write DNE for does not exist. Then I have the limit as x is approaching positive infinity. My f of x is going to become positive infinity as well. All right, and I'm actually going to clean this up a little bit. And I want to keep it in the same form. So f of x does not exist. Okay? Now, I want to go back and relate to something that we did before on our graphing pattern, because remember the square root function is coming from our parabola if there was a limit on it. So I want you to look this time. All right, so here's our graphing pattern. We're going to go 1 right, 1 up. Okay, 1 right, 1 up. We're going to go 3 right, 1 up. And then we're going to go 5 right, 1 up. And again, we would use our graphing pattern if we are trying to do some transformations. Otherwise, it's not anything that you need to really hold in your head necessarily, just to be aware. But why does this one look kind of like our squaring function? We did 1 right, and then we had the y values changing. Those y's are now our x's, And we have the x's increasing, going on the y side only by 1. Do you remember how the square root is the inverse of the parabola? So because the square root function is the inverse of a parabola with the limit of x is greater than or equal to 0, that's why this graphing pattern is flipped. So that's a good thing to keep in mind. So if you're having to do transformations, once you know this one, you just need to switch its places. Best of luck on the square root function.